Hello, lovely fifth graders. We are back, and it is time to be learning about line plots in math. So we are going to be moving on from graphing on a coordinate plane with a table, and we're going to start working on line plots and other types of graphs, kind of as a review, but also to practice a little bit more advanced line plotting skills. All right. So you might be wondering, what is a line plot? A line plot is a graph that shows the spread of data using x's above a number line. Now that sounds kind of fancy, but the spread of data just means data points or terms like in our tables from last week in math. So I want you to use this definition, and instead of discussing, I just want you to think, what is a line plot going to look like? You have had some experience with them in fourth grade. All right, I'll give you a hint. It looks like a number line, kind of. Except instead of just being a number line, we plot points above the number line to show how many times that number occurs. All right, so on this example, we have a number line that has a title. And that's what makes a line plot really a graph. Because if we just have a number line, who knows what's being represented, right? But this has a title, and the title tells you what the line plot data is all about. So this line plot is all about the number of sweets per day. Could be the number of sweets eaten per day or bought. It just depends. All right. We also have the number line. And then below the number line are the labels. So on this number line, the labels don't actually have to be numbers. They can be days of the week. They could be measurements like inches, or they could be really anything that the data is showing us, okay? And then all those X's, they show each data value or term. And if you remember from last week, a term is the data inside the table, okay? So 1X on Friday means that one sweet happened on Friday, whether you ate it or you bought it. All right, so first we're going to create a line plot. And this is the problem we're kind of solving. So it says, in April, Savannah, Georgia, which is a city in Georgia, will receive the following amount of rain in inches. And then we have down here at the bottom, we have all these data points to plot. So each number in the data is a data value, which is known as a term, which we just talked about. And each number represents the amount of rain in inches for each day. Who knows? We're going to get to that. We're going to get to that next. All right. So first, we're going to plot the data on this line, but it's just a line right now. So I'm going to need to give the line plot a title. Now I know that it's all about inches of rain in Savannah, Georgia. So I have decided on a title, but I want you to think about what would be a good title. Think in your head. The data represents the amount of rain for the month of April in Savannah, Georgia. So our line plot needs to tell others that that's the topic of our data. So I chose inches of rain in April. All right, so now, yes, it does. All right, so now we need to start writing our data in numerical order. Now, numerical order, it's chronological order. So it just means in order from least to greatest, okay? So right now, our data is all sorts of jumbled up. So I'm going to show you a really cool way to kind of keep track of where you're at and what numbers you have written down in numerical order, okay? So first, I'm going to start with the number 1, because that is the least number in my data. All right, so I'm going to cross out the number 1, and I'm going to write it down below. Then I'm going to move it over, and I'm going to move on to the number 2. And I'm going to cross out all my 2's, and I've counted 1, 2, 3, 4, 5, 6, 7, 8 2's. So I need to write 8 twos. All right, then I'm going to move on to the number 3. And I have found 3 threes, so I write my threes down. And then I need to move on to 4. I found 1 4, so I write 4 down. And then last but not least, the number 5. So I'll write 5 down. All right, so now my data is in numerical order. I need to place an X above each number as it appears in the data. So what we kind of skipped here is the labeling on our number line. So when you're labeling your line plot, you need to look at the values of your data. And the values tell us what needs to be labeled or represented on our graph. So after I wrote this in numerical order, I saw that I had the numbers 1, 2, 3, 4, and 5 to represent on my graph. So that means that our values will change depending on the data we're representing. So if I was representing the number of cookies our class ate this week, then maybe my data would look different and I wouldn't have 1, 2, 3, 4, 5 at the bottom. Maybe I would have 0, 1, 2, and that's it. Okay? So for this set of data, we have a range of 1 to 5 inches of rain. All right. So then my next step is to start placing the X's. So we've got 1 X above the number 1 for that 1 in our data. Can you predict what I'm going to do next? I'm going to place all the 2's for those 8 2's in our data. So I've got 8 X's, and notice that they are perfectly stacked on top of each other, so it's easy to see the difference between how many 1 inches we have and how many 2 inches we have. Big difference. Then I went and did the 3's, so I plotted 3 X's for the 3's. Then I plotted 1 4, and then 1 X for the 5. So there is my graph. So now we need to answer a question using our graph. How many times did it rain in April? Well, I know that each X represents the inches of rain that happened in Savannah, Georgia on a particular day in April, right? So how many times did it rain in April? It doesn't look like it rained every day. I need to look at how many X's are on my graph because that's going to tell me the number of days it rained in Savannah, Georgia. So if I counted them all up, I would get 14 X's. All right. So let's do one more. We can also plot fractions on a number line. Now this might not be news to you, but it's news for us this school year. So we are going to plot this data on our number or on our line plot, okay? So the question is, the class planted the lima beans that Ms. Rogers had brought a few weeks ago. The chart below shows the height in inches of each plant after 1 week. So they planted their lima beans, and 1 week later, this is how tall each plant was. All right, so do you remember what my first step's going to be? First, I need to put my numbers in order. So I'm going to start with the least greatest fraction. Think in your head, which fraction is the least greatest? Which fraction is the furthest away from 1 whole? It's already done for us. Number 1, or 1/4, I mean, is the least. And then you can see it goes in order. So there we go. All right. So next, I have titled my graph and I have labeled the number line. So I looked at my data up here and I said, well, we have 1/4, 2/4, and 3/4, and then 1 whole. But I want to represent 1 whole with a fraction still. And I know that 4 over 4, or 4/4, is equal to 1 whole. All right. So now, well, we already created our title. Silly willies. All right. Now I'm going to start plotting our points. So we've got our X for the 1/4 plotted. We've got an X for our 2/4 of an inch plotted. We've got 3 X's for the 3 plants that are 3/4 of an inch tall, and then 1 X for the plant that is 1 whole inch tall. All right. So now we need to answer a question with our line plots. How many lima beans were planted by the students? Well, if we think, each X represents a plant, right? So if I count up all my X's, then I will know how many plants there are. So I've got 1, 2, 3, 4, 5, 6 circles around my X's, which means there were 6 lima beans planted. All right. I want you to think for a second. Why do we know that 6 lima beans were planted? Because we're going to be working on our explanations this week. So I want you to explain it kind of like this. So we know there are 6 lima beans planted. I know this because the original information said that the chart showed the height of each lima bean. Since I plotted each height, each X must represent 1 plant. All right. What about this question? We got a new question to answer. This one says, how many lima beans grew a total of 3/4 of an inch or more? So we're looking for plants that are 3/4 of an inch tall or more. So where am I looking on my graph? How many X's am I going to circle? Think to yourself. We're going to circle the X's above 3/4 and the X on 4/4 because 4/4 is greater than 3/4, so it falls under that or more category. So how many lima beans grew a total of 3/4 of an inch or more? 4 lima beans. All right, 5th graders, that is it. That is our lima bean, not lima bean, starts with an L, our line plot lesson for this week. We are going to be working on creating your own line plots, reading line plots, and you're going to be working on fixing other students' errors for line plots. So please make sure you reach out to me if you need any help this week with our graphing practice. And I can't wait to see what you guys do. Have a great rest of your week.